Now the next problem, I'm going to show you two ways of doing that. One way is for you to say, look, the use sub doesn't work. This is the long way. Let x equal, and since that's a plus, twice the tan of theta. Take a derivative. That's twice the secant squared of theta d theta. I did take a derivative of tangent to be secant. Yeah, okay, good. I thought I messed up that one. Okay, and here, if you pay attention, we're replacing x in two places, and the x is right there. Well, we're looking at twice tan of theta squared, twice tan of theta squared plus 4, and twice secant squared of theta, d theta. So this is the integral of 4 the tangent squared of theta over 4 the tangent squared of theta plus 4. If I factor 4 out of the denominator, I notice that tan squared of theta plus 1 is really, actually, we have plenty of room. Tangent squared of theta, tan squared of theta plus 1 is secant squared of theta. The 2 I drag up front. And again, tan squared, we know that's secant squared of theta minus 1. And when you take a derivative, I'll take a secant squared tangent of theta minus theta plus c. And hey, I really don't need to create the table here. I could just say, look, tan of theta is x over 2. I could create the triangle, but it's not needed because I want the tan of theta, which is x over 2. And theta is the inverse tangent of x over 2 plus c, and if you distribute the 2n, again, this is a fine answer. That is x minus twice the inverse tangent of x over 2 plus c. Now, again, in the next section, partial fraction decomposition, this is going to be a special case. There's a quick way you could do that, and you learn that in section 3.4. I did this by using a trick before. If you recall, a student showed me this. What you do, you add 4 and subtract 4, and you split those up. Add 4 and subtract 4, not x. And if you recall how this works, this is simply x. The integral of dx over x squared plus 1, we agreed you're going to memorize that, and it was right there. The integral of dx over a squared plus x squared is 1 over a. So here we're talking about 4. So that is 1 over 2. That's what you squared to get 4. The inverse tangent of x over 2. You could have done the problem this way. That's x minus twice the inverse tangent of x over 2 plus c. Of course, trigonometric substitution works, but it's a bit longer. And you're going to learn in the next section when you're dealing with improper fractions, and what improper fractions are when the derivative of the top polynomial is not lower than the bottom. You could have used long division. You could have said, let's take x squared divided by x squared plus 4. X squared divided by x squared is 1. So this is the integral of 1, and the remainder is 4 over x squared plus 4 dx, and you have proceeded. Again, you can learn that in the next section. No need to rush it, but adding and subtracting will work as well identically. Now we get to a problem like this. These are considered the very challenging problems because at first glance you're like, okay, that doesn't look like any of those three. Well, I try a u-sub, it doesn't work. The fact it has a radical should be hinting that either you're going to square both sides, and we're going to talk about that later, or you're going to take negative, since that's a polynomial, you're going to say, wait a minute. I know how to make that a perfect squared. I'm going to add a number, and I'm going to subtract that same number. Since this number is multiplied by a negative, I have to multiply this by a negative. Take half of the middle number, which is 1, and square it. That becomes negative x minus 1 squared. 8 plus 1 is 9. So I could say this is the integral of dx divided by the square root of 9 minus x minus 1 squared. Now, I could make multiple substitutions, and that's going to make the problem a lot longer than it is, you know? So you have a choice. I'm going to copy the a minus x squared. A minus x squared. So let me copy this down. And let me put that right here. Oh, come on. Okay. Okay, here we are. Well, let's see how this plays. So here, I could use a u-sub, let u equal x minus 1. Or I could say, look, it's matching this. What's taken the place of a? Obviously, what is squared to get 9, 3? What's taken the place of x? You could say, one shot, let x minus 1 equal, a is a 3, and what? Sine of theta. You could let u equal x minus 1. This will become the integral of a du over square root of 9 minus u squared. And let u equal 3, the sine of theta. But then, when you're done, you have to create the table. And then you have to go from u back to x. That's a lot of steps. Just to get around it, simply, in place of x, use the x minus 1, and everything matches. Now what? Take a derivative. That's the x, 3, the cosine of theta d theta. Let's see what we did. We have a square root, 9 minus, and I replaced all of the x minus 1 by 3 sine of theta squared. And the x would be all of this, whatever that is. And that would be this is 9 sine squared of theta. If I factor a 9 out, that's 1 minus sine squared of theta. And this is simply cosine squared of theta. And we know this is 3 cosine of theta d theta over, and this is square root of 9 cosine squared of theta. That is the integral of 3 the cosine of theta d theta divided by 3 the cosine of theta. We're simply integrating theta. We know what that is. D theta, that is theta plus c. And do we know what theta is? Sine of theta equal x minus 1 over 3. And theta would be the inverse sine of x minus 1 over 3 plus c. Just by the way, I just want to mention, if this was a cosine or something else, I would draw the triangle. I would have said this is the opposite over the hypotenuse. The opposite is x minus 1, hypotenuse 3, and that will be the square root of 9 minus x minus 1 squared. If there's a need, but you really don't need that for this problem. Just saying. And one more problem to go. I believe that's the last one. Yes. When we get to partial fraction decomposition, there's an easy way around doing this. That is, you say, look, that's the integral of 1 over x into x minus 6. And you would say this is a over x plus b over x minus 6. Figure out a and b and go from there. But for now, we don't know about that. For now, we're going to use this complete because this is an alternative. We're going to say that is x squared minus 6x plus a number minus a number. Take half of the middle number, which is 3, and square it. So this becomes a perfect squared. X minus the number before you squared it. This is 9 minus x minus 3 squared dx. So here I could say also, oh, I'm sorry. No, it's not. It is x minus 3 squared minus 9. So if I'm looking at x squared minus a squared, x squared minus a squared, it's right there. It's that one, right? Okay. Again, this is provided on your test. You don't have to memorize this. And the final. So I'm looking at x minus, that's the first one. So I'm going to let, instead of x, which is what they have, I'm going to choose x minus 3 equals a, that's 3, the secant of theta. Take a derivative of the left, that's dx, derivative of the right, secant of theta, tan of theta, d theta. This becomes the integral of, that is 3 secant of theta, tan of theta, d theta. And the yellow part is 3 secant of theta squared minus 9. This is 9 the secant squared of theta minus 9. If I factor a 9 out of that, and this is 3 secant of theta tan of theta d theta, and tan, secant squared minus 1 is tan squared of theta. One third secant of theta over tan of theta d theta. Since this is not multiplied secant and tangent, I'm going to write everything in terms of sine and cosine. This is 1 over cosine of theta, and this is sine of theta over cosine of theta, yeah? So this is 1/3 the integral of 1 over sine, which is cosecant of theta d theta. And if you recall, the integral of secant of theta is natural log of absolute value of secant of theta plus tan of theta. Cosecant of theta is cosecant of theta minus cotan of theta. Not done, almost there. I need to take this and say, okay, well, let me get this out of the way. I need that space. So that means secant of theta is x minus 3 over 3. Secant is the hypotenuse over the adjacent hypotenuse over the adjacent. That makes this the square root of x minus 3 squared minus 9. I want the cosecant, which is the hypotenuse over the adjacent, and cotangent, which is the adjacent over the opposite. And whether you distribute that in and clear it up or not, that's irrelevant. And that's pretty much how this works. And there's our homework.